in the ionic substances, the most important thing that you have to remember is that are formed by a metal and a non-metal. So in case in the IGCSE or the GCSE, they give you a formula like all of these ones here. The first thing that you have to do is check, okay, so sodium is a metal, good, and chlorine is a non-metal. So this right away you can say, okay, this is an ionic compound. We have potassium here, which is a metal, an iodine, which is a non-metal, so you have an ionic compound, and magnesium oxide. Magnesium is a metal, and oxygen is a non-metal. And also, something very interesting here is that you have the melting points. So you can see that these ionic substances have relative high melting points. And let's talk about that later. Now, the difference of electronegativity in those ionic substances is higher or greater than 1.8. That means that the most electronegative atom is going to steal the electron of the least electronegative atom. So in this case, oxygen is going to steal the electron from magnesium. Remember, potassium is going to give the electron to iodine, or chlorine is going to steal the electron of sodium. So they become ions. And when they become ions, they have a very strong electrostatic attraction between them. Remember that the ionic compounds are arranged in a crystal lattice. And remember that lattice means a very regular and well arranged structure. In this case, the lattice is of ions. Look that in green we have chlorine atoms. In this case, we have ions, so it's chloride ions. And in purple, we have sodium ions. Look that we cannot call it a molecule because they are only just a little part of a giant crystal structure. So NaCl is just one part, or it's just the relationship that we have between sodium atoms and chlorine atoms, or sodium ions and chloride ions. Well, now, how are those particles held together? Look that in this case, we have a positive charge and we have a negative charge. The sodium is a cation and the chlorine is an anion. In this case, the chloride anion. And these ones are charged positively and the other one is charged negatively. So positive charges and negative charges will attract one another. And this kind of bond is called ionic bond. And this kind of bond is a very strong bond due to the strong electrostatic attraction between the particles. So, what are the particles that are involved in the ionic bond? Of course, ions. In this example, we have sodium ions and chloride anions. What is the relative strength of the attraction? This attraction is very strong. And well, let's try to think about how can we break the attraction forces and how can we undergo a state change in the substance. So let's try to think about the melting mechanism. When we have this kind of attraction, imagine that you want to make it liquid. And to make it liquid, you have to apply a lot of energy to break the forces. When you applied that energy and you broke the forces, you're going to have this. You're going to have ions. And those ions are basically free to move. But they are not longer in a crystal structure and they're in a liquid state. So they can move. Now, since you had to apply a lot of energy to break the forces, that's why you have high melting points in those substances. Now, can an ionic compound conduct electricity? Of course, but not always. So we have to say that yes, it does, but there is a condition here. We can only conduct electricity, and remember that when we conduct electricity is because we have charges that are moving. So in this case, remember, in a solid state, particles that move, they vibrate, but when they're in the liquid state, they're actually free to move. So we can conduct electricity. And what are the particles responsible of conduction? In this case, ions, chloride ions, and sodium ions. So yes, but only when they are in an aqueous solution or when they are molten. In the solid state, sodium chloride or ionic compounds do not conduct electricity because the ions cannot move. Good.